So yeah, I had kind of, I mean, while I was creating this design, I thought the recording is on, but later on I realized like the recording was on, but somehow it didn't save the recording. So let me just quickly walk you guys through what I have put together. It will not be the same experience as I kind of designed earlier, but let me quickly walk you guys through the design that I prepared for you guys. Today we are discussing system design problem, basically a system design of a web crawler to crawl the URLs from internet. Right, the simple statement and the use cases of this crawlers are like manifolds. I mean, the recent example being the LLM, where starting from GPT-1, GPT-2, GPT-3, three and a half, and then Llama and all of those things, they have been trained from the data that is there on the internet, and a lot of it has been crawled, like the public data that has been crawled. Billions of sites have been crawled, like a lot of data uh, have been crawled, right? And then here, like this data could be used either to train the LLM or a specific ML model, or even like building a search engine, right? All of those things could be there, but that is not the scope of the problem. We will not be discussing the pipe, like the LLM training or building search indexing and all of those things, whatever the page rank and stuff what Google had done. So we'll just be focusing on the crawler functionalities and its design. So for a crawler, like the functional requirements would be pretty simple. One, basically given a set of seed URLs, like you have to start from somewhere. You will be given some initial URLs. You will kind of take those URLs and then crawl the sites, like crawl those URLs and their linked URLs, and you kind of keep on doing that. And for a given URL, you kind of get the page content, like all the HTML content, like the raw data, and also the process, like just the textual information. Get that information and store it, right? So that it could be utilized in the downstream pipeline. Those are like two basic functional requirements that are there. Out of scope here, like we'll not be discussing LLM training or any other kind of cleanup. In terms of the non-functional requirements for the crawler, one, it has to be fault tolerant. What that means is, if for some reason the crawling process is going down, which it will, or like the crawling is failing for some reason, it should be able to retry it, like crawl the site and get the information, right? That's one. The second one is basically the crawler is respecting the policies that the site has kind of defined. Uh, like it's all I mean, it's a public internet, so it shouldn't be the case where you are kind of affecting or bringing down somebody else's site and all of those things. So a lot of sites, or most of the sites, they define like they put a robots.txt file on their sites, on a right on their domain, which basically defines some rules, like how the what the policies are, like how it should be crawled and all of those things. So the robot.txt looks something like this, like do not crawl probably the private folder, there is a rate limit, crawl gap, like gap in two requests and all of those things, how it should be like 1 minute, and all of those things. That so those are the kind of things that are defined in the robot.txt. You can say like these are the crawling rules. We should kind of be respectful for that. That's like unsaid rule for the crawlers on the internet. And third one is basically like more of a functional, and for this system design problem, like you crawl 10 billion URLs probably within a week, like in 7 days and all of those things, right? If I talk about the scale, I mean, we have given the number 10 billion URLs in 7 days, so that means like a lot of yeah, I mean, the system would be highly scalable, right? Again, going back to the NFR, because we have made sure the system is fault tolerant, so the retriability and all of those aspects would be there. And the scale is used because we have to crawl these 10 billion sites within a week with all these limitations that every site is having. A lot of retriability and stuff would be there. So our system has to be reasonably fast and it should be scalable. Like a lot of parallel processing needs to be done. Coming to the scale, let's say for every site, the content on an average is 2-3 MB per URL, and if we are scraping, let's say 10 billion URLs, roughly the data comes around 20 petabytes, or in that order, like in the order of petabytes, right? You will have some redundancy and all of those things. So, but that tells you like the data is used. You will have to have like lot of machine, lot of parallel processes. It's a high scale problem. I'll not go too much into the details. And during your interviews also, you can talk to the interviewer, which is maybe like go through these calculations only when there is a requirement, but probably you can just give a rough idea like, okay, this is a high skill system and we'll try to kind of get to whatever is required, right? I mean, we'll anyway, it gives you an idea like how your design should be scalable. Yeah, I mean, I had kind of designed this, but let me quickly walk you guys through what I have thought about here. So the first workflow, the simpler workflow would be kind of, let me just move some of these issues. I don't think I can pause, but yeah, somewhere here, like issues, we'll come back to these later on. Okay. So this is our number one issue. Okay, we'll come to these slightly later on. But yeah, so what we were saying was like there are some seed URLs like that anyway is given in input, maybe let's say the wiki.com something xyz where you start from, and then there can be like all of these URLs that are there. So what I was saying was like we kind of push these initial front load or load all of these URLs into a to be crawled URLs queue. There is a queue that we have created, uh, and then there are these processes, page crawler processes that are there. There are multiple of those. What they are doing is they are taking every URL from the crawl, making a call to DNS to get the IP, and then making a download call to kind of get the page content. And what it is doing is storing the raw content into the S3. Okay, let me just remove these for simplicity. Now we can come back to it later on and move these slightly to the other side. Okay, so here the page crawler, what it does is like in simplicity it kind of puts it into the S3, and then also what it does is we have a database here, because there is not too much of relationship, though the entries would be quite huge because we have 10 billion URLs. So roughly like URL metadata would be 10 billion entries. Domain metadata could be slightly lesser, which is like you just have the root domain, the data. So what we are doing here is basically like this page crawler is going for a given URL. It kind of is putting the raw content here, making or like first it is kind of making a entry in the database, which this database could be Dynamo or Mongo also. I chose Dynamo because that's what I can go ahead with, because I can scale up and scale down and all of those things I could do pretty easily. So I'll put it in the Dynamo. Same is possible with the Mongo also, but here we don't have like too much bigger documents and all of those things. Any of those would scale up. So for simplicity, I have just I'm just gone ahead with the Dynamo. Here I'll have two entities. One is the URL script metadata, right, which will be having the ID, some random UID. Then the URL raw content path, right, where the HTML content is getting pushed. Then the crawl timestamp, like when it was crawled, and I can have extra metadata also. The second information would be there here, which is when the for every domain I'll kind of first get this robot.txt and also put this metadata here in the domain metadata there, right? So that's what as page crawler has done. Ideally, like if I kind of given the one approach could have been to kind of everything let page crawler do everything, which is get the raw content and then do the cleanup also, get the different tags and stuff, or even find out the linked URLs. But to kind of bring more retriability and make this one faster, I kind of divide it into two parts. So I kind of put this once the raw content is done, entry is created. For the cleanup and everything, I kind of created one more queue. Let's say call it a cleanup queue, where the page crawler pushes a message. It will have the URL, raw content path, and probably the ID. Like the message would not have the raw content because the raw content, raw HTML content might be like 2-3 MB long, and we don't really need it. And also these queues or the PubSub systems don't allow messages more than 1 MB. So we'll just have the metadata here. It could just be very well be the ID also, and then content extractor is actually going and fetching it from the DB. But if it is just about the raw content that we know, we'll download it from S3 like this. What do you say? This arrow would be both sides. So this is basically one fetching the data from the S3, doing the cleanup. It does like extract the text, extract various HTML tags, store it back into the GCS. So any extra data other than the raw HTML. And then kind of what it does is it gets the linked URLs, creates a list and puts those URLs to be crawled into the URL, I mean this particular queue, so that it goes back to the crawler, right? So the here if you look at the flow, even the XYZ it kind of gets crawled. Raw content is stored in the S3. The metadata, the domain related information we have put in the domain metadata. URL related information is put here. In the cleanup queue, raw content is being cleaned. It found, let's say, 10 more URLs. It pushed it to the queue, right? So that's how our initial workflow look like. But as you can see, like there could be multiple places where it could kind of problems could start coming in. If you look at our NFR requirement, first one is the fault tolerant. Which what it means is like when page crawler is trying to get the content, it failed for some reason, network connectivity or rate limiting or anything else that is there. How do we handle it? So what it will do is like in case of failure scenarios, it might retry like once or twice on the process itself, but it can't try for longer. Or if it is failing with the rate limiting and all of those things, what it has to do is page crawler is actually pushing back. Uh, I mean, it's not really pushing back that message to the SQS, but just setting the what do you say the sets the visibility. I mean, in very simple terms, what it does is like page crawler, whenever it fails, it kind of pushes it back it to the SQS, like to be crawled SQS, and all it does is basically it kind of uh, adds some delay and push it back to the queue, right? That's there. So that again it will come back and it will kind of handle the page crawl, and this again this cycle would go on, right? uh, the second part would be basically like here, as we have to, if we go to the NFR, second NFR, which is should be respectful of the site policies. So what we are doing, we are doing is like in the robot.txt we are kind of storing it in this domain metadata if the repeated requests are coming in. What it will do is we store the all the rules that are there, and instead of making the db call again and again, what I'm thinking of is like putting a redis where like redis is having the domain metadata. Whenever a new domain came in, we have this domain metadata, and also yeah, so domain metadata is there, and which help us like which help this page crawler to determine like if I am let's say it has crawled a particular url, maybe like made a call at in last 20 seconds itself, and there is a new request, and if it wants like the robots.txt says like okay, the two requests would be 1 minute apart. In that case, what it will do is it will kind of push it back to the to be crawled urls queue, and here we have kind of purposefully taken sqs, the reason being like the retriability is available out of box in the sqs, and in case of kafka, I mean we can use kafka also for these queues, but the retriability is not built out of box. I think I got the problem. Okay, so retriability is not built, but the SQS has it. You can set the visibility timeout to some seconds, and then after that time, it will kind of take it up, or you can push it back. And after some retries, it will had keep a counter also. Maybe again use the Redis for the counter, and after those many retries, it will push it like it will push it to the dead letter queue. So that's how we are kind of planning to use the Redis for domain metadata and how it will push it back. The second part is basically like so we have handled the retriability of the page crawler if something is going down and all of those things. Also kind of how we are pushing it into the SQS. The issue could come in here like if all the crawlers are kind of, if there is a rate limit somehow happened, like again before I go into the retriability aspect, how we can kind of handle the rate limiting is again use the rate limiting and maybe the token bucket kind of approach that we can follow for the rate limiting, and whenever the tokens are expired for a particular site, in that case we kind of push it back to the queue and move on with the other requests and all of those things, right? But what may happen here is like all the crawlers they might if we are adding some delay, if all the crawlers are kind of or all these processes are adding same amount of delay, what will happen when the in the next try again all the requests would come up and some of them would start failing. So to avoid that we can add some random delays, uh, right? Some random number could be added, and that could take care of the these periodic like all the requests coming at the same time, because the randomization would take care of randomizing them at different times. So the message is the set time or the timeout or the delay that would be there, that would be random and they'll come in a random order. So we can handle that particular issue there. The other thing was because there are 10 billion URLs and we are kind of content extractor is extracting the links from pages, it may be possible that there are dependencies. It is possible that some of the URLs are already scraped, but they are coming back again in this queue. So there could be two approaches here. One, either like this content extractor itself could make use of this data, like if something is already scraped, and then push only the unique ones, but as there could be like lot many, so I am kind of adding the check here, which is whenever the new queue new URL came in, page crawler would just check in the DB where whether the URL is already scraped or not. It will do a call here. uh, if it doesn't exist, then only it goes ahead and crawls it. But in the other cases, what can happen is, I mean, as you can see, like for every new crawl request, it is making a call to the DynamoDB. Might not be very efficient, right? One approach could be where you can kind of create the indexes, right? Secondary index where like you has the URL, and you kind of do the index. I mean, anyway, you'll have to create the index, but the indexing would also might take time. So to avoid that, like to optimize it further, what you could do is you could use a Bloom filter, which is Bloom filter gives you a guarantee. Like if something doesn't exist, it definitely tell you. Like it can definitely tell you if something doesn't exist, and that's what we need. If some like when a URL comes in, we check in the Bloom filter data structure whether that URL exists. If it doesn't, then we go ahead and crawl it. If it is, then we don't. There are some ways like in which it will kind of we might skip some of the URLs, but that should be fine because then we can. It depends on us how big the Bloom filter we can make. And as we are using Redis for all these caching and all of those things, uh, the Redis provides inbuilt data structure like Bloom filter data structure, so we can put it there, and that can handle our these queries of figuring out if something is already scraped or not, and that can save a repeated request, right? So those were a couple of issues, like one that we have already discussed, already scraped. Already crawled URLs or scraped URLs. In that case, we'll use the Bloom filter. Even the indexes are also quite fast nowadays with the modern databases, so should be fine. But for better, I think Bloom filter could also be. I mean, good would be a good use case here for the Bloom filters. Right, that's one. The second one is page scroll delay. We have already added. We'll add some randomization. Third issue could be here, where like what could be the issues to achieve those 10 billion requests within 7 days, because these processes would be quite high. So the DNS calls to DNS are way too high. In that case, we can add a cache for DNS also. So let me just write it down here. DNS cache, DNS cache, right? I hope that gives you an idea. This is how the workflow would look like. Coming to this part, right, there could be two kind of pipelines that could be built. One could be where you are kind of reading the S3, maybe like using Spark, right? Some Spark engine is here, which is uh, right based on some cron. Some cron would be here. You can have your training pipeline, or maybe the indexing pipeline could also be here. That could be maybe a simpler one, like could be a real time one, or could be another one also. That's how you can kind of utilize this data either from S3 directly or from content extractor in the real time. Yeah, so that's how it looks like, and I guess it takes care of all the functional requirement, non-functional requirements. Yeah, cool. Let me kind of go back here. Sounds good. Let me just hope it was helpful.